All right, and we are back, and we're here with Why Are You Sleeping? Uh, Otherwise known as Jeremy Johnson offline. So Y has been working towards Filecoin for many years. His work started with IPFS and building the technical foundations for the protocol and the implementations. He's been through every single project in the network. He then worked on pulling out all of the core of IPFS and creating Liquid2P. So he's been very involved in that project as well, in establishing the direction and foundations of that networking stack, and so that it could be used for a lot of different protocols. He's been involved in a number of open source communities over the years, including Ethereum, and a lot of different package managers and Arch Linux and others. And more recently, he's been the tech lead for Filecoin. He was also the team lead for Lotus and the Lotus implementation. And nowadays he's working on all kinds of different areas of the project all over the place. So, yeah, it's a great honor and very excited to be here chatting with you. We're gonna talk a bit about Y's vision for the future and what he's excited about. Yeah, welcome, Mike.
Yeah, thanks, Juan. Thanks for the intro. It's great to be here.
Awesome. So let's talk about the tech for a few minutes. So can you talk to us about what's there in the network now? What works today? What can people do with it?
Yeah, so the Filecoin network today is honestly really cool. There's, we got a long ways to go, but what's there right now is pretty huge, and in terms of volume and in the magnitude of what we've done. So we have well over 600 petabytes of data right now on the network. Not all of that is real data. It's a lot of committed capacity, but that's how much capacity the network has at this moment, which is what, a couple weeks after launch. Pretty crazy. Some of the things I'm really proud of with this network is really how impressive the amount of computation this network is doing is. Everybody's computer who has a synced Lotus node right now is verifying daily all of that storage, 600 petabytes of storage. Everybody's computers are verifying that that's correct. It's there, it works, it's the right data. And that's ridiculous when you think of my laptop with a node running on it. It is using one or two CPUs a lot, but hey, it's verifying a ridiculous amount of data. The amount of SNARKs that we are using on this network, I think, is greater than the number of SNARKs on any other service system ever. So pushing the boundaries of scale there pretty significantly. Additionally, if you were to take Filecoin and remove all of the ZK SNARK proof and all the storage proof stuff and just look at the raw capacity of the network, we could handle 10,000 messages, sends of transactions, money per block. And then since the way that Filecoin works has multiple blocks per round, you could have 50,000 transactions per tip set. So that's 50,000 transactions every 30 seconds, which is 1.6 thousand transactions per second, which is ridiculous. And so most of that space right now is taken up by submitting those SNARKs on chain, but there's so much Slack space for as much value transfer as you need, which I'm really proud of how efficient we've made that whole setup.
Yeah, that's really a huge monumental feat of engineering. And curious. So right now, a lot of the SNARKs and the proofs are taking up a huge portion of the capacity on the chain. But is that going to continue that way? Is that going to scale in a different way, or can you talk to us about kind of the future of that?
Yeah, so the SNARKs right now is the obvious problem that we're working on, and when building Filecoin, we really had to thread the needle between getting it working now and making it work for the long future. And so we made a bunch of shorter term decisions, such as using Bellman as it exists now and not looking for new, more exciting SNARK proving libraries, because Bellman worked. It is a thing, it's proven, it's hardened, it's there for us. So we built using that, knowing that it wasn't going to last us for the long term. And so now we're looking at all sorts of other different SNARK systems, in particular Halo from the Zcash team again, is a really exciting setup that allows us to do recursive SNARK proving, which allows you to take as many SNARKs as you want and compress them down into a single SNARK, which really in a lot of ways kind of just solves the too many SNARKs on chain problem. And so some of our next steps are going to be looking into new proving systems like this to allow us to increase the scale and capacity of the network just dramatically. And so really excited to see where that goes. There's so much happening in the world of like ZK SNARK systems that like pretty much every week there's like a new proving system out there, and it's just hard to even keep track of how fast it's moving, let alone like, have a good picture of what the right thing to use is yet.
Yeah, that's super exciting. And yeah, look forward to getting a lot more of that capacity on the chain and the scalability that will come there. Yeah, let's maybe shift towards maybe some of your vision for the future. What are the kinds of applications that you're excited about? What does Filecoin make possible that wasn't possible before?
Yeah, I mean, one of the things that isn't necessarily like the most exciting application, but one of the things that personally affects me a lot is just having package managers and a lot of dev tooling and all of this be put onto Filecoin and into IPFS and Filecoin, and it really more distributed peer-to-peer settings where I spend I don't know how much time cumulatively in my life I spent downloading packages and waiting for these things to update because it's this thing stored on some crappy server in some university basement somewhere, when it really is used by so many people that it should just be peer-to-peer. Like I guarantee somebody else in my house or around me has this data already. Like why can't I just fetch it from there? And so seeing Filecoin be adopted in these different use cases where it's huge amounts of data that is already like effectively content addressed, and just having that be all put on Filecoin for everybody to use is a really like front of mind thing. Another cool thing that I'm excited about is like with the rise of machine learning, you end up getting a lot of data. Like everybody says big data, but the scales of what people mean when they say big data is usually only in like hundreds of terabytes, really, maybe into petabytes. And when you start to go beyond that, like how do you even think about that much data, and how do you store, how do you manage, how do you like retrieve that massive amount of data? And the cool thing is like the way we've designed Filecoin can handle exabytes and zettabytes of data. Like it'll just do the thing and work, right? So I'm excited to see like uptake of Filecoin usage for storing data for like these huge big machine learning projects.
Yeah, that's super exciting. And earlier today we had a talk from a group that's already writing a tool for people to do machine learning over Filecoin data, and so it's already getting going, which is great.
That's awesome.
What are the when we have these massive scale data sets, terabytes to petabytes in size, that is really difficult to move over the internet, right? So it's a huge amount of data that would occupy many disks, and putting that kind of throughput through the internet would take many months in most connections. So talk to us how that would work with Filecoin.
Yeah, the poor throughput of the internet itself has been a recurring theme of work at Protocol Labs. I remember early designs of Filecoin, we had this assumption where we're like, okay, and we're going to shuffle the data around to prove that everybody has it. And then we did some back of the envelope math to be like, no, that's actually 1,000 times more than the carrying capacity of the internet. So we can't do that. A huge problem that many people designing like systems, computer systems have is that like, well, actually the internet is really slow. And so with Filecoin, we've designed it so that it doesn't rely on a particular way of moving data. It doesn't care how the data gets there. You can make a deal with anybody, and then if they eventually get the data, great, the deal can go through. And so we've initially designed so that you can, ship somebody hard drives filled with data, right? Maybe like even like a big, huge box of disks, and like have the miner on the other side import all that, and then your deal can go through because they've, received all of this data. And I think more interesting things are going to adapt over time, because as demand for moving this data grows, like basically the goal of Filecoin is to reduce the actual cost of the storage down to nothing. But then that doesn't yet account for like the the cost of moving that data. So as we reduce the actual long-term costs of storing the data now, there becomes more of an incentive to figure out how to make moving it faster, cheaper. And so I think we're going to see a lot of interesting, ways pop up to move data more efficiently. Whether that's like interesting backhaul with, there's like optical backhaul where you can move like terabits of data over shorter distances just through, wireless optical links, or who knows, like maybe there's some interesting satellite technology that can do similar stuff. There's a lot there.
Yeah, that's super exciting. And let's touch a little bit more on the DevTools package managers use case that you described. So DevTools are a huge part of developers' lives, of course. In package managers specifically, people are constantly installing different versions of software, either from source or package binaries or various things like this. How do you see that evolving? So there's a lot of registries out there, and then there's kind of the source code on GitHub and a few other areas. There's a lot of people always kind of frustrated with the centralization of these kinds of registries, and people want to be able to have higher levels of security and assurance around their code and the binaries. People have been trying to build decentralized versions of these things, but a big hurdle has always been, who's gonna manage all of this data? Who's gonna store all of this data? When you start adding up the terabytes and you deal with the bandwidth costs, that can be pretty big. So how do you see that kind of thing evolving? And what do you think kind of kicks us off and gets us there? Is it like one of the big package managers that exists now kind of moving over and kind of having mirrors, or is it kind of like a new package manager? Yeah, how do you think it's going to play out?
Yeah, I think this is a hard space to move in because it's entirely built around like adoption and network effects. I think the package manager space is like so tightly built around network effects that it's hard to move it. I think one of the key things to start in that direction of breaking up that network effects is to kind of separate the data layer of packages from the actual registry layer. So if you have, a registry just contains a mapping of, names to hashes, and that's it, right? Names to hashes and like a version list or something simple like that. And then from there, you can go get the data from wherever it happens to be. Separating this out and then making it so that the data is stored somewhere safe, somewhere where it's, backed up nicely, and that me as a user of packages can skip the registry layer once I've already resolved the package once. So like, for example, npm install something and locally it references, an IPFS hash, and that if npm goes down or npm has problems or whatever, I don't need npm to get my data. I don't need npm to keep installing my packages. I can go straight to the network. I can go search an IPFS. If it's not there, I go retrieve it from the Filecoin network, where all the packages can be just stored on the Filecoin network for long-term storage, just to make sure they're there forever. And that gives us a lot more safety and resiliency to our software ecosystem over time. And I think there's definitely room for new package managers to be built, and for new package managers that focus on this trusted hashing and moving the data around, like effectively building a registry that is maybe curated by some token, for example, or has some way to have better curation around it than just like whoever lays claim to the name first. And since if you have that separated from the full package manager suite, then it becomes easier to swap those out and use a different curated registry for different things.
Yeah, that's I think that idea of separating the data layer from the registry is a really, really good one, and we should work on getting that propagated out there. Great, so maybe let's move to some of the kinds of applications that maybe are coming ahead, especially with new kinds of interfaces. So I know that games and virtual reality are pretty interesting to you. They are to me and many other folks in our community. Yeah, talk to us about some of that kind of stuff. What are the kinds of games that you think are now possible in this Web3 world? And maybe talk a bit about kind of where virtual reality is coming.
Yeah, there's a lot here around the virtual reality. One of my favorite books is Snow Crash. For those who've read it, you have this persistent virtual world, and one of the biggest questions you get into when you have this persistent virtual world is the question of ownership of space, because when you have a shared space, you have to worry about like who owns what and where, who's allowed to make changes where. And really, like, blockchains are a natural fit for managing that sort of thing. And so having a some sort of curation of a space through the blockchain and having management of ownership of, like, this Black Sun place in the metaverse is owned by me and I'm allowed to make changes to it. That sort of thing is really I think a good fit there. And then this brings up the other side of VR, in that as you get into more and more compelling immersive landscapes, the amount of data you have to move around there is huge. Like, you imagine how big just a video game that you play on your TV is. And those are like 60 to 100, 200 gigabytes worth of files. And that's not something that's fully immersive and all around you and has all these extremely detailed models that you get to interact with. The amount of data that it's going to take to make a really compelling VR game is going to be massive. And I don't know, I feel like the internet can't even handle that much data as is. And so systems that allow you to fetch the data from better sources and more nearby sources and move it peer-to-peer better, I think are going to be necessary in order to enable this future VR world. Things like, if you have some experiences in VR that need to have data moving directly peer-to-peer in order to have high enough bandwidth to properly engage, I think that's a really exciting place to be.
Yeah, and some of the problems that emerge in VR once you start scaling experiences in around the world, like you suddenly have millions of people in there. If you start generating any kind of content in large volumes, not only do you have a large amount of data to kind of broadcast out, but suddenly you have generation of vast amounts of data all over the edges. So a peer-to-peer network is set up in a way to support that kind of application and that kind of platform in a way that other centralized systems are not. How do you see this sort of evolving with, how do you sort of expect the internet to evolve, to adapt to that kind of throughput requirement?
Yeah, I think we're definitely going to see a lot more bandwidth from like edge to edge. So like things like 5G are interesting because they're such short range technologies. They're about the same range as Wi-Fi, really, where it gives you extremely high bandwidth, but just to people nearby. And I think as these things evolve, like the bandwidth to move data from where you are to nearby, like I think people will have more reasons to just share huge amounts of data with the people that are closer to them than necessarily farther away, just because, well, the way that experiences are going to be shaped, like, for example, I'm trapped inside in quarantine, right? Because I can't go outside because there's evil viruses out there that are trying to kill me. Well, my friends are still nearby. My friends are still in the same city, right? And if I want to spend time with them and I want to spend quality time with them, like, it's the internet connection required is just between me and there. It doesn't need to go like overseas or anything. And so as we get these faster and higher bandwidth edge connections, it allows you to have like more interesting virtual worlds with people you would normally see in person. And I think that's a thing I'm kind of interested right now, is like, how can we have more how can we have a better experience online with our social connections, maybe through VR, maybe through something like that, but the way that bandwidth is going to evolve affects that significantly.
And maybe it might be useful to kind of touch on what's at stake, right? So with these new interfaces and these new platforms coming into our lives, and a large fraction of our activity kind of going through them, especially once VR and AR get very high quality, we stand in the way of falling into the same kind of lock-in that we have today with the social networks, as opposed to the much more open web that we had early on. I know that this is something that you care a lot about. Can you talk to us about kind of how do you see the possible futures, right? Like what's like the bad future that we should avoid, and kind of like what's a good future that we want to get to?
Yeah, I mean the bad future we're trying to avoid is really Facebook mind controlling everybody with their fancy Oculus devices. It's it's the boogeyman that everybody worries about, and I think it's a very tangible concern. And making sure that all these platforms and protocols are open and free and usable by everybody is really important here. That the data you need to access in order to participate in these new worlds. This is like as I see a future where society spends a lot of its real time in VR and in these worlds, and if that access is restricted by some entity or some corporation, it's a really dystopian, like scary world where somebody like Mark Zuckerberg could decide that you're no longer able to participate and interact with your friends and your life, and can just kind of cut you out of your life because as these interfaces become more and more central, like the access to them becomes even more and more like a basic human right. And so making sure that the data and the access and the protocols are open and freely accessible is a hugely important problem here. I recently got one of the Oculus Quest 2s, and it forced me to make a Facebook account, which I'm very concerned about. I made a fake Facebook account for it anyways, but who knows? That's what it's going to require of me in the future, and what restrictions it's going to try to impose on the things that I do with it. That's concerning.
Deeply so. And with the current, thankfully, there's been kind of a more recent awakening to the problems that the social networks have created in terms of the abilities to manipulate people through those environments, the ability to spread fake news and misinformation and all kinds of issues. But really, what you're talking about is an even deeper level of lock-in and manipulation, right? So it's not just kind of a reality created by information flow on a kind of low quality social network page, but we're talking about the 3D environment that people will spend a huge fraction of their time in, being fully controlled and designed by potentially a few gatekeepers, right? And so but then decide who gets to see what. And so like that kind of dystopia is pretty scary. How do we avoid it? So what do we need to do between now and like the 10 years out? That's 5 to 15 years out that it's going to take for those technologies to develop. How can we paint the vision of the good future, and how do we get there?
Yeah, I mean, I think a vision of the good future is, well, you have the access to all of these future devices and all of these future experiences and interactions is the same or better than we have on the internet today, where you just go to a website, it's an open protocol, it's open access, like it's kind of your browser vendor generally doesn't get in the way of what you're seeing and what you're doing. Firefox isn't going to tell you, no, you can't go to that website. Although sometimes it does if their HTTPS cert is bad, but that's different reasons. And the tools you use to access information, shouldn't ever be able to have a say, and should never be able to have a say in what you see and view. And so getting people in to build on these protocols and build with open protocols and build experiences that everybody wants to show that there is demand for this, I think is important here. Like getting in and building out the tooling and building out just actual things that are using open protocols as a way to start cementing that in place as how this works is kind of how we avoid that. Because you see how much time people spend on Facebook and Twitter and so on now. Imagine how much time you're going to spend and how immersive it's going to be if VR is incredible and you just slip on your glasses and now you're in a whole nother world. Like that, you want that to be, the choice to be on the user.
Yeah, and so for the Filecoin community members out there, what should we prove out this year and next year and the next year to start making Web3 and the open web ready for that kind of future?
Yeah, I think we need tooling. I think people who are excited about this stuff should start build apps and demos and just build games even that use Filecoin, use IPFS as the place to get their data from. And in doing so, I think we'll discover a lot of different things that will help us build the right tooling and help us build the right knowledge about how to do this in a free and open way.
Great. Well, with that, let's end there, and let's lead the charge on making sure that that next platform is open and stays open and is locked open. Thank you very much for sharing your time with us, Wyatt, and
Yeah, thank you.
looking forward to an awesome year ahead.